Alright guys, starting 2.4 is your last lesson for the week. Just remember 2.5 and review next week, and then we'll have the tests next week for cohort B will be on the Wednesday, and then cohort A you guys are going to have it on the October 5th, which is the Monday. Okay, rule of sum. Okay, so it's the same kind of formula as we did for probability in the first chapter, but now we're doing for n, which is the number of ways. So if we remember, the probability of A occurring is the number of ways A occurs over the total. So we're kind of taking just the number of ways and we're breaking it down now. So number of ways that A can occur and the number of ways B can occur. Just remember, when you see the or, when it's an or, we have the addition. When there's an or, there is an addition. And we're going to have two, so that's the rule of sum. But then we have the inclusion and exclusion, which is the same thing, but again, we're subtracting any overlap. So we have the same formula here, the or, but again, we subtract if we have any overlapping answers or things that we've counted twice. Okay, so let's go in number 1. A math department means, at math department means there are 8, 9, or 10 teachers who attend. If they sit in one row, how many different arrangements are there? Okay, so key word here is the or, so that means we're going to be adding 8, 9, and 10 together. So we're going to find the number of ways for 8 plus the number of ways for 9, and then plus the number of ways for 10. So if we just look at the number of ways 8 can be arranged in a row, so going by yesterday's lesson, 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 teachers sitting in a row. So when I said anytime you see a row or a line, we're going to do the same thing. So we have 8 options for the first spot. So we have 8 teachers. We can put one of those 8 teachers into the first spot. After we have removed the first teacher, then we have 7 teachers remaining, and then 6, and then 5, all the way down to 1. Okay, so which is 8 factorial. So the number of ways 8 teachers can sit is 8 factorial. Okay, now if we look at the next one, which is 9 teachers sitting, that would be plus 9 factorial. And then lastly, we have 10, which is 10 factorial. So 8 factorial plus 9 factorial plus 10 factorial. Let me see, 10 factorial plus 9 factorial plus 10 factorial gives me 4,032,000 different ways that 8, 9, or 10 teachers can sit in a row in the classroom. Okay. That's that one. Okay, number 2. Okay, so pay attention to these ones because you're going to see these a lot. 3 players each. 3 players each cut a card from a standard deck. If order is important, which is this whole chapter, if it is important, in how many ways could they pick all hearts? Okay. So we're going to each cut a card from the deck, but we're going to replace. Sorry. So there'll be no replacement. Okay, so they cut a deck from the deck of cards. We cut a card. So they pull one out and they get a heart. They pull one out and they get a heart. Okay, so then the first person has a heart. Okay, then they say, well, we're going to take it, and now we're going to cut another card, and the next person pulls out a heart. Okay, and then the third one does the same thing. So what is the probability that that will occur? Well, we have to look at how many hearts there are, and then we're picking 3 of them. So how many ways can we pick it? It's not the probability, but how many ways can we pick it? So there is 13 hearts, and we are picking 3 because the order is important. 13, let's see, where's my thing? 13p3 is 1,716 ways that 3 people can pick 3 hearts from the deck. Alrighty, which is 13 times 12 times 11. Okay, next one. What is the number of ways? What are the number of ways that they can pick all aces? Okay, so how many aces are in a deck? Is 4, and we are picking 3 of them. So 4 pick 3 gives us 24. Okay, so 4 aces, and we're picking 3 of them. Okay, and lastly, all aces or hearts. All aces or hearts. Okay, so all aces would be 4p3, or is plus 12p3. Okay, but here we have to be careful, because if we have to check to see if we have any overlaps. Well, is there any aces and hearts that we counted twice? Yes, we counted the ace of hearts twice. So then we're going to subtract 1 at the end. Okay, so we have 13p3. Oh, it's those ones. So 7, 16 plus 24, subtract 1. So that would give you 1739. Okay, moving on to our last one. Okay, so we have number 3. How many ways could the letters in the word, your favorite F word, factor? So how many ways could the letters in the word factor be arranged? Okay, so be arranged. So how many letters do we have? We have 1, 2, 3, 4, 5, 6. So we have 6 letters in the word factor. We want to see how many ways we can arrange all 6 of them. Any word is always in a row or in a line. So if I'm if we're rearranging or arranging 6 letters, all of them, then it's just 6 factorial. Okay, or you say, write out the spots. You have 6 letters options for the first spot. Once you use 1 letter, you have 5 remaining for the next spot, then 4, 3, 2, 1. So we have 6 factorial. So is that 2, 6, 12, 24 times 30. 720 ways we can rearrange those 6 letters. Okay, and now we're into something where this is very similar to the lesson that we just did with the people sitting in a row. Okay, so here it says, how many ways could the letters in a word factor be arranged if the vowels are to be together? Okay, so if you remember in 2.3, we said, well, the 2 vowels have to be together, so A and O, they have to be together. Then we have the other 4 spots, the other consonants can move any which way they want. So the consonants are 4 factorial. But in 2.3, I also told you that this is one group. That one group is considered, can move in any spots together. So they can move here, 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 or here. So they can move together around these 4 factorial. So we have one group. So one group and 4 factorial, so that makes it 5 factorial. Okay, so 5 factorial. And then I said, there's one extra part to this. Well, the A and O could be in this order, or they could be in the flipped order of O and A. So we're going to take the 5 factorial and then times it by 2 factorial, because the A and the O can switch positions. So 5 factorial, let's do 20 times 6, 120 equals 240 ways. Just want to double check that. 5 factorial times 2 is 240 ways. Okay, so again, we have the 4 consonants can move in any positions they want, plus 1 group of vowels. They have to be together, but they can move in the spots as long as they're together. So now we have 5, so 4 plus 1 is 5 factorial. So it's not 6 factorial anymore, because we have a group. So now it's 5 factorial, and then we times by 2 because the A and the O can move positions. Okay, and the last one, if the vowels are not together, so the same as yesterday, is this the number of ways in total? This is the number of ways they are together. To find the number of ways they're not together is to just subtract it. So if we take 720 and subtract 240, we get 480 ways they cannot be together. Okay? If you want to put the factorials in the question, so it'd be 6 factorial, subtract 5 factorial times 2 factorial. Okay, that concludes the lesson 2.4. Your homework is there at the bottom, so page 86, 1 to 4, 6, 7, 8, 9, 8, and 11. Okay, and if you have any questions, you can ask me at the homework session Friday afternoon, or you can ask me in class on Monday if you like to. No, you guys are, well, some of you guys will be here on the morning. For Monday, please also have 2.5 printed out, and we'll be continue 2.5 and then the review section. Take care. Bye.